All right. Lesson 8.2 is a review of all the trig that we've learned so far. Okay. So what I want to do on example 2, we are going to write the trig ratios. What do I mean by ratio? Fractions. Okay. So what's our reference angle that they want us to use? It wants to find the ratios of f, so that's our reference angle. Remember, circle your reference angles. So starting with sine, we'll do sine first. So sine of our angle, which is f, sine of f. What is, sorry, I got a little ahead of myself. Let's label the sides that we have so far. What can I label 9? That's the opposite side because we're cutting across the triangle. What's 15? Hypotenuse, because we're across from the 90 and it's our longest side. What about 12? That's the adjacent side because it's right next to. Okay? So, sine, SOHCAHTOA, what is my sine ratio? Opposite over hypotenuse. What's opposite? 9 over hypotenuse? 15. Can I leave my answer like that? No, we want to reduce when we can. What can I divide both of these by? 3 to get 3 over 5. Okay, next one, we want to find cosine of our angle F. Cosine, what's cosine's trig ratio? Adjacent over hypotenuse is cosine. What's the adjacent side? 12 over hypotenuse, 15. What can I divide both of those by? Divide both those by 3. We get 4 over 5. And then the last trig function, tangent of our angle. It's opposite over adjacent. So what's opposite? 9 over 12. Divide both those by 3. We get 3 over 4. Okay. Once you have the trig ratios in simplest form, that's all you need to do. Okay. Number 3, I know it's a 30, 60, 90, which is awesome that some of you recognize that, okay? Because you could use the 30, 60, 90 model to help you find the missing sides. That's awesome, okay? I want to practice it with trig for now, okay? Later on, I will give you the options of what you want to do, okay? So here, we're looking for that missing side. I understand we have 2 reference angles. You can pick one. I'm going to show you both of them. Okay, so the first one I'm going to do is I'm going to use 60 as my reference angle. Okay, so what do we do once we have our reference angle? Label the sides that we have. Okay, so we have a side Y. What can I call that side? That's the hypotenuse. What about 9? That's the opposite in regards to that 60. Yep. So once we have our sides labeled, we are going to pick the trig based off of what we have labeled. Okay, so we have opposite and hypotenuse. Out of sine, cosine, and tangent, which one uses opposite and hypotenuse? Sine. Sine uses opposite and hypotenuse. I'm going to ask you this. Is sine the only correct option? For opposite over hypotenuse? The only one I can pick is sine. If I pick cosine, is that right? No. So based off the sides you have, there's only one correct option out of the 3. Okay? So in this case, it is sine. So I'm going to start with sine of what always goes with the trig. What was my reference angle? 60. So sine of the angle equals, yep, opposite over hypotenuse. So we go 9 over y. I'm going to put this over 1. Why do I put that over 1? Right. This helps you visualize the cross multiply, right? But I did teach you a trick. Here, are we going to multiply or are we going to end up dividing? Dividing y. We're going to flip them, right? So that trick, if y is on the bottom, these two are going to end up switching places. So what's this turn into is y equals 9 over sine of 60. Okay, so you type that in your calculator. If you type 9 divided by sine of 60, what do you get? 10.4. Okay. Now, I'm going to erase my picture. Actually, before I do that, if I change my reference angle to 30, do my sides change? Which one stays the same? Start there. Hypotenuse is always going to stay the same. Okay, so opposite is going to switch. So if I change my reference angle to 30, okay, what is 9 in regards to 30? That's the adjacent side. So which function uses adjacent and hypotenuse? Cosine. So we're going to pick cosine. So cosine of, what's my reference angle? 30 equals adjacent over hypotenuse. 9 over y. Similar idea here. Are we going to end up multiplying or dividing? Dividing. Again, what happens between those? They flip, right? So y and cosine of 30 switch spots. If you type that in your calculator, what do you get? We get the same thing, right? 10.4. So it didn't matter which one you use as your reference angle. Okay? And if you did the 30, 60, 90 way, okay, you probably have a square root in your answer somewhere. Just multiply that out, you would get 10.4. Okay? Let's look at C. So it says given sine of 65 is 0.91. What is the approximate value of cosine of 25? How do you think we can figure that out? What is this 65 and 25? Is that a side or an angle? That's an angle, okay? How can we figure this out without a triangle? How can we figure out the value of this? Type it in your calculator. Type cosine of 25 in your calculator. What do you get? 0. Do you agree that you get the same as what sine of 65 is? Why is that the case? Right, it's exactly like the same example above. Do you agree? Is that what you were saying? Okay. In the example above, yes, we had two different angles here, but did we end up getting the same answer? Okay. Why do you think that is the case? Let's do some comparing. Why are we getting the same answer? Right, they're finding the same thing. They're in the same triangle. Okay, 60 and 30, what do they add up to? 90. What do 65 and 25 add up to? 90. Okay, so they're a part of the same triangle. That is why they are getting the same answer. Okay, but the reason I did that example is because I want you to understand, if you ever see a question like this where it asks you, okay, find cosine of 25, or okay, find sine of 65. That's just something you can type in your calculator. Okay, there's no math involved there. You can just use your calculator directly. Okay, so I'm going to give you a random one. Find tangent of 45. Tangent of 45. What'd you get? 1. Again, what does that 1 mean? It's a side length, right? Whatever we're finding here, just like this one, we were finding a side length. That's what this is finding. Okay, let's try one more. Cosine of 32. Let's round to an eighth. 0.8. Again, what is that giving you? It's giving you a side length. What is different about example 5 and what it's asking compared to what example 3 was asking for? It's asking for an angle this time, okay? What have we been looking for? We've been looking for sides. So whatever we're looking for, this is our reference angle. So go ahead and circle P of your reference angle. We're going to set these up in a similar way. Okay, so once we have our reference angle, what did we do after that? Label the sides. What is 2? That's opposite of P. What's 3? Adjacent to P. So now we pick our trig. Which trig uses opposite and adjacent? Tangent. So I'm going to pick tangent. What do we normally put with the trig? The angle. Well, what's my angle? We don't know. So it's P. Or you can put theta. Yep. So we're looking for P, right? So P is my angle. I'm going to put that with the trig. Equals, now like normal, what's my tangent ratio? Opposite over adjacent. Yes, it's 2/3. Now, what's a little different here is we're trying to look for this angle here. Okay? We want to get rid of tangent. It's that tangent -1, tangent inverse. Okay? So to get rid of this tangent, we're going to multiply both sides by the inverse. That -1 means inverse. Okay? So multiply both sides by the inverse. I'm going to rewrite this for you. Watch what happens. On the left side, those cancel out because they're inverses. Okay, so I'm left with our angle P equals, I'm going to rewrite that right side as tangent inverse of 2/3. Okay, this here is what you're going to put in your calculator. Okay, when you see that that fraction bar, think division in your calculator. Okay, what did you get for angle P? You should get 33.7. Again, what did this give you? It gave you the angle. So on part B, I'm looking for Q. So can I use what I have labeled from angle P? Why not? Right, my reference angle changed, so my adjacent and my opposite are going to change. What is opposite of Q? 3. And then what is 2? It's right next to, so that's your adjacent side. Again, once you have your two sides, you pick the trig. Which trig function has opposite and adjacent? Tangent. So we have tangent of,
3/2.
Careful. Tangent of Q. Yep, remember that angle goes with Q. If you're skipping this step, that's fine. Okay. Equals what? 3/2. Some of you went directly to this, which is totally fine, as long as you understand what's going on. Okay, but remember how I get to here, we want to get Q by itself, so I'm going to multiply both sides by the inverse tangent. Okay, and then this cancels it out, and then this side gets me to here. If I type that in my calculator, what did you get for angle Q? 56.3. And again, what does this give you? Gives you the angle measure. Yep. What Julio just asked, and it was a really good question. Okay. Do you agree angle P and Q are a part of the same triangle? Yes, right? So what should these add up to? They should add up to 90. Is that true? That is a way to check, especially if you're using the same triangle. Yep. Why should they add up to 90? Because this third angle here is 90. All of them add up to 180.